Hey everyone, welcome back to the Programming Professor channel, where we dive deep into the art of writing clean, maintainable code. Today, we're exploring a crucial topic that can make or break your software projects: meaningful names. This video is based on the wisdom from Robert C. Martin's Clean Code, specifically the chapter on naming, and I've distilled it into a set of slides we'll walk through together. Good naming isn't just a nice-to-have. It's a game changer for readability, debugging, and teamwork. So, let's get started and see how we can level up our coding game with better names. Writing clean code, the art of meaningful names. Based on meaningful names, from Clean Code by Robert C. Martin. Alright, here's the roadmap for today's video, based on our slide outline. We'll kick off with an introduction to why naming matters so much in software. Then, we'll dive into intention-revealing names, how to make your code tell its own story. We'll cover avoiding disinformation to keep things crystal clear, and making meaningful distinctions so your names actually mean something different when they should. Next up, we'll talk about using pronounceable names because, let's face it, we need to talk about our code without sounding ridiculous. Searchable names are on the list too, making it easy to find what you're looking for in a sea of code. We'll also tackle why encodings are a relic of the past we should avoid, and then look at solid conventions for naming classes and methods. Adding meaningful context will tie it all together, and we'll wrap up with best practices and pitfalls to watch out for. It's a packed outline, so let's jump in. Names are everywhere in software development. You're naming variables, functions, arguments, classes, interfaces, packages, source files, and even directories. Studies suggest we spend about 70% of our coding time reading code, not writing it. So poor names ramp up the mental effort needed to understand what's going on. On the flip side, good names act like built-in documentation, cutting down on the need for extra comments. Investing time in choosing the right names pays off big. It boosts maintainability, reduces bugs from confusion, and makes code reviews a breeze. Think of naming as the foundation of clean code. It's where clarity begins. Let's look at some common naming traps with a few examples. A variable like int d might mean elapsed time in days, but it's cryptic. Someone reading this has to guess or dig through comments. Same goes for int n for number of users or string s for user status, zero context. Then there's vague stuff like the list or a function called process, what's being processed. And don't get me started on magic numbers. Employee type equals 7, or sleeping a thread for 86,400,000 milliseconds. What do those even mean? These are all red flags that make code harder to follow. Now, let's flip those examples into something better. Instead of int d, use elapsed days or days since last login. It's immediately clear what's being tracked. Swap the list for active users and process for calculate monthly payroll. Now you know the purpose without a second thought. Replace flag with is eligible for promotion for clarity. And those magic numbers. Turn them into named constants like employee type contractor or milliseconds per day. Suddenly, the code speaks for itself, and you're not scratching your head trying to decode it. Here's a real-world example from a Minesweeper game to hammer this home. The original code snippet is a mess. It's got a function called getThem that loops through the list and checks if some value at index 0 equals 4, then adds it to a new list. What's the list? What's index 0? Why 4? What's this list even for? Without context, you're lost. It's simple code, but it's implicit, forcing you to play detective to figure out what's happening. Now, check out the improved version of that Minesweeper code. First step, rename getThem to getFlag cells and the list to game board. Boom, you know it's a board and we're looking for flagged cells. We define constants like status value and flagged to replace the magic numbers. Even better, the final version abstracts it further with a cell class and an isFlagged method. Same logic, but now it's explicit. You can read it and instantly get what's going on. That's the power of intention-revealing names in action. Disinformation is another naming pitfall we need to dodge. It's when names mislead you, like calling something a count list when it's not a list, or HP, which could mean hypotenuse or Hewlett-Packard. Then there's userinfo versus user data. Are they different? Who knows? The fix is simple. Use clear, unambiguous names consistently across your codebase. If you're unsure, err on the side of being more explicit. Misleading names are like planting landmines for the next developer. Don't do it. Let's talk about making meaningful distinctions, because slapping random numbers or noise words on names is a lazy habit. Name 1, name 2, name 3 tells you nothing. Why are they different? Same with product data, product info, product object. Those extra words are just fluff unless they mean something specific. And check out this code snippet. Copying chars from A1 to A2, it works, but it's meaningless to anyone reading it. These are distinctions that satisfy the compiler, not the human. Here's how to do it right. Use first name, last name, and full name instead. Each name carries its own weight. Replace vague terms with product, product catalog, product inventory. Now you know what each one does. In that char copying code, switch to source and destination. Suddenly, it's obvious what's being copied where. Meaningful distinctions aren't just different. They tell you why they're different, making your code a story, not a puzzle. Pronounceable names might sound trivial, but they're a big deal. Stuff like genumdums or DTA RCRD 102 is a tongue twister. Try saying that in a meeting without tripping over yourself. Rename them to generation timestamp or customer, and suddenly you can talk about them naturally. This matters because programming is social. You're discussing code with teammates, reviewing it, onboarding newbies. Pronounceable names cut cognitive load and make communication smooth as butter. Searchability is another naming superpower. Take this code snippet, a loop with J, S, and T, plus magic numbers like 34, 4, and 5. Searching for J or 5 in a big codebase is a nightmare. You'll get hits everywhere, and good luck figuring out which one matters. Single-letter names and raw numbers are like hiding your code in plain sight. Functional, but impossible to track down when you need to. Contrast that with this cleaned-up version. Constants like work days per week and number of tasks replace the magic numbers, and variables like sum and task number give you something to grip onto. Now you can search for number of tasks and find exactly where it's used. No guesswork. Searchable names make your code a breeze to navigate, especially in larger projects where context is everything. Encodings are a relic we should leave behind. Hungarian notation, like SDR name for strings, or prefixes like M, for members were hacks for weaker compilers and IDEs that couldn't track types. Same with sticking I on interfaces. Back in the day, with limited tools and name length restrictions, this made sense. Today, modern languages and IDEs handle types for us, so encodings just clutter things up and make refactoring a chore. Let's ditch them. For class and method names, stick to clear conventions. Classes should be nouns like customer or address parser. They're things, not actions. Methods should be verbs like post payment or save. They do stuff. Accessors and mutators follow the get, set, is pattern like getName or isPosted. This snippet shows it in action, clean, consistent, and intuitive. It's a simple rule that keeps your code predictable and professional. Context is king when it comes to naming, and this code snippet shows what happens without it. You've got number, verb, and plural modifier in a guessStatistics message class. but on their own, they're opaque. What are they for? The method, make, builds a message, but you have to reverse engineer the logic to figure out it's about guest stats. Without context, even simple code feels like a riddle. Here's the same code with context dialed up. A helper method, create plural dependent message parts, breaks it down, and sub-methods like there are no letters make the intent pop. The variables still work the same, but now the structure and names scream, I'm building a message about guesses. Good context turns a vague blob of code into something you can skim and understand instantly. Let's wrap up with some best practices and pitfalls. Go for descriptive names that reveal intent, keep terminology consistent, and scale name length with scope. Short for locals, longer for globals. Stick to team conventions, and don't hesitate to refactor when you find a better name. Watch out for overusing abbreviations, reusing names confusingly, or getting too specific or too vague. And don't fear renaming. Clarity trumps tradition every time. So here's the takeaway. Good names reveal intent, banish ambiguity, and make distinctions that matter. They're pronounceable, searchable, and free of outdated encodings. They take effort up front, but save you way more time down the road by making your code self-documenting and maintainable. Don't shy away from refactoring names. It's a small price for huge gains. Thanks for watching. Drop your thoughts or naming horror stories in the comments. Thanks for watching. Let me know in the comments if there are other topics you would like me to talk about. If you enjoyed this video, please like, share, and subscribe for more content on software engineering and technology. See you next time.